Okay, so right now we're going to go ahead and start talking about long division. There's one word that I want you to be really familiar with, okay? And this word is algorithm. A-L-G-O-R-I-T-H-M. Algorithm. Anybody have any idea what the word algorithm might mean?
It's a step-by-step process, like to solve a problem.
You absolutely stole my definition. I love it. Okay? That's absolutely what an algorithm is. So I want you to write out to the side, step by step process. How many of you wash your hair? This is crazy. Have you ever looked on the back of the shampoo bottle? What does it say? Wash, rinse, repeat. Guess what? That's an algorithm. It's a step-by-step process. And the great thing about math is you will have these traditional algorithms, as we're going to call it, that if you follow these steps, you will always get to the answer. All right? With division, we have a 5-step process. Okay? But before we get into that, I want to make sure we understand the parts of a division problem. So division problems can be written 2 different ways. We can write them horizontally, like this. That first number, 25, what do we call him? What part of the problem is him? Is he? He is the dividend. Okay, so we're going to label that as the dividend. I'll try to zoom in just a little bit. So that is the dividend. The second number, when it's written this way, he has the most important job. What does he do? He is the divisor. It's kind of like he sounds like the Terminator or some sort of superpower. He is the divisor. Okay? And the answer to a division problem is the
Quotient.
Excellent. Quotient. Okay? So we have the dividend, we have the divisor, and we have the quotient. But we won't always see a problem written this way. Sometimes we'll see it set up that we can go ahead and solve the problem. So, this is going to be really cheesy, but I promise you, you won't forget it this way. Sometimes, especially when you first were introduced to division, how many of you had trouble remembering which number went in the house and outside the house? Okay, so dividend, he's a brand new rock star. Okay, he's got this long hair. He does an epic guitar solo. All right, and the child is chanting. The crowd is chanting, "Dividend is in the house." Okay, so just picture him. He's this rock star. Okay, so this means he is always where? In the house. Okay, so this will always be your dividend. And the guy hanging over here in the wings, he's our stage manager. Okay, he's always outside, right? He's not on center stage. He's at stage door. That's right. So we call him the divisor. Great. He really does most of the work. He makes the dividend look good, right? Okay. And again, the answer to our division problem, quotient. So those are the 2 ways you will see a division problem. Guys, those are words you need to be familiar with. Dividend, divisor, and quotient. Understand what they do, okay? Alright, so let's go back and talk about that algorithm. The one that is specifically for division. Have you ever heard of this? I'm going to slide this over just a little bit. Does McDonald's sell, oops, my S is kind of bad, cheese burgers, or as I like to say, does my sister chew bugs? Okay?
She does.
So this, does McDonald's sell cheeseburgers? That is going to take you step by step through your traditional algorithm for division. All right? What in math does the D stand for? Divide. I think it also stands for does, but divide. Okay, what about the M?
Multiply.
You got it. Multiply. S? Okay. C, I almost gave it away. Check. And we're going to talk about specifically in a minute what we're checking, okay? And then the last one, bring down. Okay? And the great thing about math, guys, this never changes. So you will follow these steps over and over and over. Every time you divide, it will never change. I'll give you a second to get those written down. Then we're going to do some examples together. Okay? Yes, I'm going to give you just a second. Yes. Yes. Not yet. We're going to do it together. All right, everybody good? Okay, so following our algorithm, looking at this problem, 298 divided by 7, what is our first step? What are we going to do? Divide. Can 7 go into 2?
No.
No. Can it go into 29?
Yes.
Yes. Now, how many times? 4. Where am I going to put the 4? Over the 9 or the 2? 9. Because, guys, I don't want to look at this problem and say that I'm telling you 7 will go into 2 4 times. It's got to go over the 9. So now we multiply back. 7 times 4 is? Okay, what do I do after multiplying? And that gives me 1. Now, here's where we're checking. Okay? I'm going to zoom in just a second. What I'm checking, and that's the C part of my algorithm. Make sure I didn't mean to zoom out. I'm checking to see that this number is smaller than my divisor. Why, or what would be wrong if it were not smaller than my divisor?
You could divide it one more time.
Absolutely. I could take, if I had put 3 up here, and I had 8 when I subtracted, I could take a whole group of 7 away again. So that tells me that my number up here is not large enough. So once I know that this number is smaller than my divisor, what do I do next? Bring down the next number. Okay, and that's 8. Now, we've gone all the way through every step. Guess what we do now? Start all over again. And I'm telling you guys, this is why math is awesome, because you will do the same things over and over and over. Yes? Well, we're going to make it interesting. We're going to add some stuff in there later. All right, so how many times will 7 go into 18? 2. Multiply back. 2 times 7. 14. Subtract. All right. Okay, so hang with me. Why am I not going to use the letter R? Anybody know? We want to write it as a fraction. Absolutely. Our remainders are a fraction. But do you know what the letter R in math stands for? Not remainder. Say it again. Somebody said it.
Reduce.
Not reduce. I thought you said something. Stands for radius. That lowercase r stands for radius. A radius deals with circles. We're not doing anything with circles here. So we're not going to use that lowercase r. We want to write our remainders as a fraction. And that's because that's what they are. They are a part of what's left over. How many do you have leftovers at home? Okay? What do you do after you've had dinner and you have leftovers? Where do you put them? In the fridge. Well, in math, and again, I like to give you weird ways to remember stuff. In math, your leftovers are always going to go on the top shelf of the fridge. So whatever you have left when you're done will always be your numerator. It will always be on that top shelf. Okay? And your divisor will be your denominator. Can I simplify 4/7? No, because I don't have a number larger than 1 that will go into both of them. All right? Let's do one more. Yes?
If you check it, though, and you multiply 42 times 7, won't you have to add your 4 together?
Yes, you will, because if you get 42 times 7, it should come out as 294, and then you would add your leftovers, your remainder back to it. Yeah, absolutely. Okay, so we've got 300 divided by 45. Can 45 go into 3?
No.
Can it go into 30?
Yeah.
Oh, no. It can go into 300. But I don't know about you guys, I don't randomly count by 45s. I just don't. But it's close to something that I know I could count easily by. 50. So let's estimate. How many times will 50 go into 300? 6. So let's try that. And remember, I'm putting the 6 all the way over here. Okay? Instead of coming over to the side and having to write another multiplication problem, let's do this. What is 6 times 5?
30.
I'm going to put my 0, and I'm going to carry my 3. What is 6 times 4?
24.
Plus 3.
27.
So there I've done all of my math in one place. So now we have, it is as close as it's going to get. We have 300 minus 270. What do we have left over? 30. Let's check. Is 30 less than 45?
Yes.
It is. So my leftovers go on the top shelf.
Couldn't you simplify that?
I absolutely could. Excellent idea. What do you guys think?
15.
Divide them both by 15. So there will be 6 and 2/3. All right, any questions so far about long division? Hopefully this was a refresher. We're going to do some more practice together in a minute.